Hello, this is Mr. Agbamu Idonogrene. I'm here to teach you mathematics on the topic product rule in differentiation. And all I want you to learn in today's video is how do you differentiate two functions when they are multiplying each other. A kind of situation like this, when you have something like y equals to, let's say, 2x plus 1. So this is a function. So when this function is multiplying another function now, let's say something like this now, you put it in bracket 2x plus 1, or let's say 2x plus 3, then it's also multiplying another function, let's say 5x minus 6. So this is a good example. So you have a function 2x plus 3, it's multiplying another function 5x minus 5. So how do you differentiate a situation like this? But some people may ask, why can't I just open this bracket? Then after expanding this bracket now, opening of these two brackets, then differentiate it. We still get the same answer. But there are some cases whereby the two functions, you cannot easily multiply them. So how do you do in such situation? Like, let's have a question like this. If I have a kind of a question that says 3x squared, so something like this now. So let me put root first. Let's say root, have 3x root 3x squared, something like this. Then you now have x, let's say x squared plus 1. So if you are asked to differentiate this one, so if you don't have the knowledge of product rule, this question may be difficult for you to differentiate. Because if you apply the basic rules of differentiation to differentiate this by saying 2 times 3, which is 6x, then what about the roots? If you also use the function of a function here, at the end of the day, you see yourself confusing yourself and you may not get the correct answer. Why not just apply what product rule says we should do and you get your correct answer? So let me just keep this in one corner. We are still going to solve it as second example. So let's look at this. So this is what product rule says we should do. Let me put it in statement so that you can get it well. So product rule says if you have two functions, let's say something like this. So if y, let me use mass mode, if y is equals to uv, so and uv now, where u and v are functions, u and v are functions of x, where u and v they are function of x. So you see now, so if y is equals to uv, that means u is a function, v is a function, and they are function of x. What I mean by function of x, that means 2x plus 3, I can take it equals to u. So if u is equals to 2x plus 3, so u is a function of x. You can see it. That's what we mean by u and v are functions of x. So by the time you get this condition, and then what are you going to do now? Then product rule says, so this is product rule, then the y dx will now be equals to, you pick the first value here, which is u, you put it down u, then you multiply it by differentiation of the second function. You pick the first function v times differentiation of the second function, which is dv dx. Then not all, you add plus, it's always addition, take note, it's always addition. Then plus, you pick the second function now, which is v, then you multiply it by differentiation of the first function, which is du dx. So that is all with the formula for that is for product rule. This is all you need. If you remember this formula for product rule, you can differentiate any two functions that are multiplying each other, whether this or this, even exponential, logarithmic function, exponential function, trigonometric function, any function they ask you to differentiate, as long as they are multiplying each other, product rule will work, and this is the formula you are going to use. So let me use it to differentiate this. You will see what we are going to get. So take note of that, don't forget it. So whenever you hear product rule, So this is what we mean by product rule. Take note of this. Just like chain rule we did the other time. So take note of chain rule, take note of product rule, take note of function of a function, just like that. So if I want to differentiate this question now, so how am I going to differentiate it? Let's move up. So how am I going to differentiate it? All I just need to do is I'll say let's. So let u equals to the first function, which is 2x plus 3. Then the next thing I will now do is du dx. I will now differentiate u with respect to x. Du dx is equals to what? Is equals to 2. So that is that. Take note of that. Then the next thing is the second function now, which is 5x minus 6. Let v equals to that. So v is equals to 5x minus 6. Then you need to differentiate this, which is now dv dx. Dv dx is now going to be equals to, which is 5. Just follow your basic rules of differentiation, you will get the answer. So there's nothing so special about what I'm doing here. So that is this. Then what next? The next thing you need to do, go to your product rule formula. So your final answer, dy dx, will now be in this form. It says pick the first function, which is u, that is 2x plus 3, put it in bracket, 2x plus 3, then multiply by dv dx, which is 5. It's multiplying 5, then you put 5 here, then plus, you pick the second function, which is v, which is 5s minus 6, put it in bracket, 5s minus 6, then multiply by du dx, which is 2. It's 2. So that is that. The next thing is for you to open bracket, to collect like terms, add like terms, and the rest. So that is all. So dy dx will now be equals to, when you open this bracket, you're having your 10x plus 15. Times 5 times 3 is 15. Then plus, this is 2 times 5x, which is also 10x. 10x minus 12. And your final answer for this question, which is final answer now, which is dy dx will now be equal to 10x plus 10x will give us 20x. 20x plus, so 15 minus 12 will give us 3. So this is your answer for this question. So that's how you use product rule to differentiate product of two functions. So take note of that. So let's apply it here. Let's see. Let's apply it to this other question. So let's take this as a number 1. Let me take it as number 1. Sorry. Let's move it down. Okay. Let's take this as number 1. Alright, so this is number 1. So let's take this as number 2 now. So if we take this as number 2, let's give space. Okay, so if we are to differentiate this one now, y equals to 3x squared square root x squared plus 1. So what will you do to differentiate this? To avoid wasting time, all you just need to do, so you say let u, so let u equals to the first function, which is 3x squared. That is all. Let me come down a little. Okay. Then the next thing is to differentiate du dx. Du dx is going to be equals to 6x. Just follow your basic rule. That's how you differentiate this. Then the next thing you need to do is v. So now let v equals to the second function, which is square root x squared plus 1. So let me put it in index form, because we are going to use function of a function. You remember our function of a function class, how I explained this. So square root of two terms like this, we use function of a function. So we have x squared plus 1, then raised to power half. So that is square root. So that is that. Then the next thing is we need to differentiate this, and when we are differentiating this, what are we going to do? We say the v dx will now be equals to, so when we use our function of a function method, so I say differentiate it as a single function, so half is going to multiply the coefficient of this bracket here, which is 1, so I have 1 over 2. Then you leave this as a single function, put it in bracket x squared plus 1, then raised to power 1 over 2 minus 1, which is going to give us, let's put the bracket back, which is going to give us raised to power minus 1 over 2. So, but we are not stopping here. Then the next thing is ddx of whatever is in this bracket. We need to differentiate what is inside this bracket, which is this. We are now going to use it to multiply this variable function here, which is x squared plus 1. So by the time you get this, the next thing is you put them. Okay, let's finalize this before we put it into the formula. So the v dx will now be equals to, so the v dx will now be equals to what now? 1 over 2. Then remember this bracket is raised to power half, so I'm going to have 1 over this value raised to power half, which is square root, let's not forget, which is 2 root x squared plus 1, so that is this, then times x squared plus 1. Our x squared plus 1, when you differentiate this x squared plus 1, ddx of x squared is going to give us 2x. So 2x is actually coming to multiply 1, which is finally going to be 2x. So the differentiation of this one is complete now. So let me move it down to this place so that we can see it well. Alright. Okay. So that is the differentiation of dv dx. So if you take note and do it well, so this is correct. So the next thing is we need to substitute it into our dy dx, into our product rule formula. So we start with dy dx now. So dy dx will now be equals to u, which is 3x squared. We're going to multiply dv dx, which is this. So which is 2x divided by 2 root x squared plus 1, and that is that, then plus the next formula says v, which is this. Let me put it in the root form, which is square root x squared plus 1, then it's going to multiply 6x, which is du dx. That is it, du dx. So when you put this like this, so you have no problem. So the next thing is to solve it downward, and that is all, to the lowest form. So 2 can cancel out these 2 here since they are common. So I'm going to have 3x squared times x, which is going to give us dy dx, going to be equals to 3x raised to power 3, then 3x cubed, 3x squared times x, which is 3x cubed, then divided by root x squared plus 1. So that is the end of that side. Then plus, so let's put 6x first. Let me put my root first, which is 6x. So 6x is multiplying this root. No, 6x cannot times the value inside this root, so it's not possible. So you leave it outside, then you have x squared plus 1. So actually I can stop here. This is my answer to this question, but in depend you can still go further if you notice that you can still simplify further. So we can still simplify this one step further by just finding the LCM. So I can find the LCM of both sides. which is square root x squared plus 1. That is the LCM of both sides. So the y dx will be equals to, so let me get my denominator, let me delete this. So my denominator is going to be square root x squared plus 1. So that's my denominator. So you know the root now. X squared plus 1 divided by x squared plus 1 is 1. Then 1 times this numerator is going to give us 3x raised to the power 3. That is the end of that, plus then square root x squared plus 1 divided by 1. You know this denominator is 1, which is this same value. Then square root x squared plus 1 times 6x square root x squared plus 1. So what will happen, since these two they are like terms, you know the square root will cancel out the square root. So what we are going to have is plus 6x open bracket x squared plus 1. So that's what we are going to have when you simplify it very well. So the next thing is for us to open this bracket and check what is like terms and complete our work. So the y dx is equals to now. So the y dx is equals to, let's open this bracket and see what can come. Okay, 6x times x squared. Now this is going to give us 3x raised to the power 3 plus 6x raised to the power 3. 6x times x squared will give us 6x cubed, then plus 6x. So that is the numerator, divided by square root x squared plus 1. Then finally these two are like terms. I will now have 9x cubed plus 6x cubed, so which is now going to give us, let me finalize the answer now, which is now going to give us the y dx. The y dx is equals to 9x raised to the power 3 plus 6x divided by square root x squared plus 1. So this is the answer to this question. So take note of that. So this is all about product rule. Follow everything we did today. Product rule, following the rules. Take note of the condition for product rule. Take note of this example. If you actually expand this bracket before solving, you will still get the same answer after differentiating. You know, when we expand this bracket, 2x times 5x is going to give us 10x. So if you differentiate 10x squared, you know, 2 times 10 is 20. You can see it. Then 2 minus 1 is 1. So you will still get the same thing, but instead of using that method, instead of expanding that method, why not just use product rule? Because it's better you know how to use product rule. Like situation like this now, there's no way 3x squared can multiply the square root. It's not possible in mathematics. So but with product rule, you can see how we solved it down and we got the answer now, which is 9x raised to the power 3 plus 6x over square root x squared plus 1. So take note of all we did today. This is all I want to show you in today's video. So I hope you enjoy this class. And before I go, I have some few questions for practice. So you can practice these few assignment questions. And that is all I have for you today. I hope you enjoyed the video. Do have a nice time. Take care.